Hi everyone! So today we are going to be talking about Lewis dot structures. This is really going to expand on this idea of our covalent bonding and how two atoms can come together to form a covalent bond. A big idea of today is going to be this octet rule. We're going to talk about a couple of important exceptions, but usually our atoms like to have 8 electrons in their outer shell, 8 valence electrons. And these Lewis dot structures are going to help us to really visualize and represent how atoms bond through sharing electrons. Remember, with covalent bonds, we are always looking at sharing electrons. We figured out in our ionic bonding unit how many valence electrons each of our atoms have. And we can use these patterns on the periodic table to help us in this unit as well. So remember, the number of the column that each atom is in is going to represent the number of valence electrons it has. In other words, these Roman numerals correspond with the number of valence electrons that each one of these atoms has. If we look at our note sheet for today, let's first take a look at hydrogen and chlorine. So let's look at the Lewis dot structure of hydrogen to begin with. We know that hydrogen has 1 valence electron. In our Lewis dot structures, we will include both dots and lines. 1 dot represents 1 electron. And we will look a little further into what lines represent as we move on throughout today's explanation. So we know that hydrogen has 1 valence electron, which therefore means that whenever we draw hydrogen in a Lewis dot structure, we'll include it with 1 dot. Hydrogen is contributing 1 electron to whatever it's bonding with. If we look at chlorine, we know that chlorine has 7 valence electrons. Again, just a reminder, we know this because when we look at the periodic table and find chlorine, it is in our 7th column, which means 7 valence electrons. So when hydrogen and chlorine come together, they can form this covalent bond of sharing electrons. Hydrogen will contribute 1 electron, and chlorine will contribute 1 electron. When this happens, if we look just at chlorine, you'll be able to see that chlorine now has not only 7, but 8 electrons around it. And when we look at hydrogen, hydrogen now has 2 electrons. Hydrogen is one of these exceptions to the octet rule. It likes to have 2 electrons in its outer shell. This is what makes it the most happy or the most stable. So hydrogen is one of those exceptions to that octet rule. Instead of having 8 electrons, it's happy with just 2. So let's try a couple of examples so that we can figure out exactly how we put these Lewis structures together. So let's first look at H2O, or water. Our first step is going to be to make a table including what atom we have as well as how many valence electrons that atom comes with. So for hydrogen, when we find hydrogen on our periodic table down here, we know that hydrogen has 1 valence electron. So each one of our hydrogens comes with 1 valence electron. Oxygen, on the other hand, has 6 valence electrons. Again, you find that just by looking at your periodic table. So we're first going to draw the Lewis dot structure for each one of these atoms. Hydrogen has 1 electron that comes with it. Another hydrogen, once again, has 1 electron. Oxygen has 6 electrons. And the way that we represent this is we kind of think of this atom as having 4 sides. So if you think of it as in a box, and each side of that box holds 2 electrons. So we're going to try to fill up each side of the box one at a time, and then add 2 wherever possible. So we want to make sure that every side has 1 electron before we begin to add 2 to any side. So we fill up all sides, but that only gets us 4, which means we need to add 2 more electrons to this oxygen atom to get it to 6. So now all of these individual atoms have the correct number of valence electrons around it. If we look just at oxygen, oxygen has 6 valence electrons, but it wants 8. Remember that octet rule. So it's going to need 2 electrons to fill in and get it to 8. Hydrogen, remember, wants to have 2 electrons. So each one of these hydrogens is going to be able to gain 1 electron in a covalent bonding process. So now that we have the valence electrons and Lewis structures drawn for each one of our individual atoms, we can figure out how to arrange them together and form a covalent molecule and covalent bonds where each atom is satisfied and has the proper number of electrons to fill the octet rule, or in hydrogen's world, we're only going to be looking for 2 valence electrons. So what I'm first going to do is kind of color code some of these elements so that we can keep track of what's happening. So our hydrogen and the valence electrons belonging to our hydrogens I'll keep purple, and our oxygen and its valence electrons I'll keep orange. So I'm going to move over here. We've got oxygen, which has 6 valence electrons. And then we have 2 hydrogens, each of which has 1 valence electron. So remember, our hydrogens, they want 2, and our oxygen wants 8. So if we're just looking here, we see that we have an empty space here for oxygen, and an empty space here for hydrogen. Same thing goes here. So what if oxygen allowed hydrogen to share this electron and this hydrogen to share this electron? That way both of these hydrogens would each have 2 electrons. Similarly, oxygen wants 8 electrons, so by doing this, hydrogen then could share this electron with oxygen and this electron with oxygen. So therefore, our hydrogens each have 2 valence electrons, and our oxygen has 8 valence electrons, satisfying all of our rules and making all of our elements happy. So each hydrogen atom is going to attach its free electron in the oxygen atom, creating a bond here. So in our Lewis structures, a bond is represented by a line. So we will have oxygen with its valence electrons connected to 2 hydrogens. So each line then represents 2 electrons, since one of them is from hydrogen and one of them is from oxygen, but now they're sharing them, so we can form it as a line or a covalent bond between these 2 atoms. So this would be the Lewis dot structure of water. Each hydrogen is bonded to we call this the central oxygen atom, since it is between these 2 hydrogen atoms, which are both sticking out in either end. The oxygen has 2 bonds, each of which has 2 electrons each, so if we count up the number of electrons on our oxygen atom, we'll see we have 1, 2, 3, 4, 5, 6, 7, and 8. Exactly what we want. Satisfies all rules of the octet. Each hydrogen wants 2 electrons. We can see that this hydrogen has 2, and this hydrogen also has 2. So all 3 of our elements are happy. Let's look at NH3, which is ammonia. First we need to figure out how many valence electrons we're working with. So we have 1 nitrogen, so if we look to our periodic table, find nitrogen, you'll see that the Roman numeral above it is 5. So nitrogen has 5 valence electrons, and each of our hydrogens have 1 valence electron. So I'm going to draw out the Lewis structure for each one of our atoms here. 1, 2, 3, 4, 5. So nitrogen has 5 valence electrons, and each of our hydrogens has 1. Remember, nitrogen wants to have 8 to get a full shell. Hydrogen wants to have 2. So each of these hydrogens is missing 1 valence electron, and our nitrogen is missing 3 valence electrons. So when we start to put these things together, we've got our nitrogen with 5 valence electrons, and each of our hydrogens has 1 valence electron. You can see that when we connect the dots between these single valence electrons, we are satisfying all octets. So if we draw this back out with the lines representing covalent bonds, 2 electrons being shared between 2 different molecules, this is what we end up with. This hydrogen has 2 valence electrons. This hydrogen has 2 valence electrons. Same here. And our nitrogen has its total of 8 valence electrons, satisfying the octet rule and making all atoms happy. Alrighty, one last example here that's a bit trickier. First, again, we're going to figure out our valence electrons for each individual atom. We have H, C, and N. So H, we are at 1. C, over here, we're at the Roman numeral 4. And N, which we've done already, is 5. So I'm going to fill that in. And then draw the individual Lewis structure for each one of these atoms. C, we have 4. And N, we have 5. So a quick trick, carbon is usually going to be our central atom whenever we have a carbon involved. So that's a good place to start. But you can always play around with it and move things around as needed. But I'm going to put carbon in my center and then draw the other 2 atoms around. So as we can see here, we have lots of electrons that are single, that aren't paired up. So this is usually where we form bonds. So I can see this would be an obvious bond to form. We could form one here, we could form one here, but we still have some single electrons left by themselves, and we know we need to get 8 around each of our carbon as well as our nitrogen. So maybe we need to change around our drawing a bit. So with these electrons, as long as they're all around the nitrogen, it doesn't matter where our pair is. So it might make sense to put our pair on this side in our drawing here. And this will allow us to connect the dots, really, connect these lone electrons. And what you see is we have 3 bonds between our carbon and nitrogen. So if we draw this a little bit cleaner now, we have 1 bond between our hydrogen and carbon. Hydrogen now has 2 electrons, just like it wants. If we draw 3 bonds between our carbon and nitrogen, that's using up this electron, this electron, this electron, as well as these 3 from our nitrogen. And then our nitrogen still has these 2 electrons left over. So some of these questions are actually kind of fun because it's a bit of a puzzle. You kind of gotta draw it out. If it doesn't work, start from scratch again, just try to figure it out. But if we look here, our hydrogen has 2 electrons, which is exactly what we want. Our carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Again, exactly what we want, that octet rule. And if we look at our nitrogen, we've got 1, 2, 3, 4, 5, 6, 7, and 8. So with these covalent compounds, we want to make sure that every atom satisfies its octet rule. Of course, there's some exceptions like hydrogen over here, which only likes 2 electrons. So there you go. Lewis structures. Have a great rest of the day.